So here is the key to the quiz that you took today. And notice in number 1, we're asked to find where f has a relative max. We're given a graph here of f prime. So this is a graph of the slope of f. Now, whenever we have a relative maximum, we're looking for places where the derivative changes from positive to negative. And that only occurs at -2. Here, f prime takes on positive values, and then it's 0, and then it switches to negative. Now, at 1, there's no sign change. It's negative, and then 0, and then negative. So -2 is the only place where we have a local maximum. In part B, we want to know where is f both concave down and decreasing. Where is it concave down and decreasing? So f prime is decreasing. F prime is decreasing. That will give us part of the answer. And where is f decreasing? That's going to be when f prime is negative. So what we have to do is analyze this graph, and we want to find out when is this graph decreasing and when is it negative. Now it's decreasing here, all the way here, but here it's positive, it's only negative down here. So what I'm looking for is from -2 to -1. F prime is negative and it's decreasing, and also from 1 to 3. So we have two intervals, from -2 to -1 and from 1 to 3. Now for points of inflection occur when f prime changes from increasing to decreasing or from decreasing to increasing. And if we look at our graph, okay, if we look at our graph here, we can see that f prime is decreasing, and then it is increasing, and then it is decreasing, and then it is increasing. So we have points of inflection at -1 and at 3, -1 and 3, where f prime is going from decreasing to increasing, right? Decreasing to increasing. But we also have another one at 1, where f prime is going from increasing to decreasing. For part D, we have to write an expression for f of x. So here f of x is 3 plus. Now this 3 comes from the fact that we are told that f of 1 equals 3. And so we now have 3 plus the integral from 1 to x. And then I'm going to choose another variable different than the x here. So I'll use t, and we're going to integrate f prime here. Okay, f prime. So f prime of t dt. And then we have to figure out what the value of f of 4 is. Now, we are told in the original problem that the assigned areas in these regions, okay, the areas in these regions, this is 9 and this one is 12. Okay, so when we integrate, then we would have 3 plus -12, and that answer would give us -9, right? Because we're starting from 1 here. So this has a f of 1 is 3 minus 12. But then when we integrate from 1 to -2, then this signed area is going to be positive. So I wrote this as 3 plus 9. You can also think of it as 3 minus the integral from -2 to 1. And that would give me 3 minus a -9. It's going to give me 12. Now for part 2 here, for natural log, it's 1 over sine. And then we have to use the chain rule. The derivative of sine is cosine of 3x times 3. Now you end up with cosine over sine. You could rewrite that as cotangent, but I'm just going to leave it like this. If it was a multiple choice question, this would probably show up as cotangent. Remember here, tangent squared means the quantity tangent to the second power. So chain rule is 2 tangent to the first. And then the derivative of tangent is secant squared of 4x and then times 4. So that's the final link in the chain rule. For part C, e to the x, the derivative of e to the x, or e to the u, I'm sorry. So this is e to the arctan, and then the derivative of arctan is 1 over 1 plus 2x, quantity squared, and the chain rule, we're going to multiply that by 2. So if I were to simplify this, this would be 4x squared here. And then in part D, I'm going to use the quotient rule. And so we have the denominator, derivative of the numerator, numerator, derivative of the denominator, all over the denominator squared. Now if I wanted to simplify this a little bit more, this would be negative 2x squared plus 2.